All right, so let's continue on with lesson 7.2, unit 7. So we'll start off with saying that energy is going to be conserved. So chemical energy is the energy that's stored in chemical bonds. We've talked about this, and there's an example here. Um, most of energy that powers living things or non-living things are going to be stored in chemical bonds. For instance, the um, energy in sugars created by photosynthesis is really what drives and provides ATP for all living organisms. So this is why we must balance chemical equations, because the law of conservation of matter and the law of conservation of mass. So chemical equations summarize reactions by using formulas for each substance. Because of the conservation of matter, the left side or also known as the reactants, must equal the right side, which is also known as the products. So how do we do this? All right, well, number one, you write the equation. All right, so you write the reactants and products as chemical compound formulas and elements. For example, right here, H2 plus O2 gives us H2O. All right, so this is how you start. You write out the chemical equation. Next, you draw a table and fill in all the elements in the equation, as well as how many atoms of each element are on each side of the equation. All right, so example, we wrote out the equation. We have the elements, the reactants, which are going to be the left side in this particular equation, products on the right side. So the elements that we have hydrogen and we have oxygen. Those are the only two elements we have in the whole. Let me get my laser. That we have in the whole chemical equation. Okay, so we put hydrogen and we put oxygen down here in the table. The reactants on the left side, how many hydrogen do we have? We have two hydrogen. This two right here tells us we have two hydrogen. How many oxygen? This two tells us we have two oxygen. Okay, so we have two of each on the reactant side. On the product side, we have two hydrogen. Okay, so the two will go here. We have one oxygen. How do I know I have one oxygen? Because there's no subscript following the oxygen, so it tells me that there's just one. So I put one right here. All right, so that's step number two. Step number three, if the reactant numbers are not the same as the product numbers for each element, you have to balance the equation. So what we mean by that is we look at the numbers. On the left side, or reactant side, we have two hydrogen. On the product side, we have two hydrogen. Hydrogen is balanced. We have the same number on both sides of the arrow. If we look at oxygen, however, we have two oxygen atoms on the reactant side, one oxygen atom on the product side. That is not equal. Okay? We have to have two of each, or two on both sides. Okay, so we have to balance this equation. If all these numbers, if the number of oxygen on both sides was equal and the number of hydrogen on both sides was equal, we would not have to balance. It's already balanced. All right, so number four, step four, add coefficients in front of the formulas until they balance. Remember, you can't change the formula by changing subscripts. You can only change the atom of the substance, the amount of the substance you have. Subscripts are set in stone. You can't change those numbers. We have to add coefficients in front of the atoms or compounds in order to change how many atoms we have. So for example, and sticking with the example that we have, right? So H, hydrogen, O will be for oxygen, okay? So, boy, this did not line up well. All right, so we knew we only had one oxygen over here. We had two oxygen over here, okay? All right, so we put a 2 in front of this entire compound, which gives us two oxygen. We had two oxygen here, okay? But this 2 also is going to be applied to the hydrogen atom, okay? 2 times 2 is 4. So now we have 4 hydrogens in our products, means we need a 2 in front of the hydrogen here, okay? All right, so if you want to pause right quick and try these practice problems, all right, I would suggest it, and then the next slide is going to be the answers, and then I will move forward. Okay, so if you want to pause the video again, try to balance these, see what you come up with. Use the table or not, that's up to you. But remember, you want to have the same amount of atoms of each of the atoms on both sides of the arrow. Okay, so if we're looking at this first one, we'll explain the first one and then pause it and try the other ones. Mercury, okay, you have one atom of mercury here, one atom of mercury here. They're balanced, okay? Have one oxygen atom here, I have 2 oxygen atoms here. They are not balanced. All right, so I have 2 over here, 1 over here. I'm going to put a 2 as a coefficient right here with this compound. Okay, so now I have 2 oxygen on the reactant side, and I have 2 oxygen on the product side. But that 2 also goes to the atoms of mercury. All right, so 2 atoms of mercury here. I need to put a 2 as a coefficient here for 2 atoms of mercury, and that should balance me. So again, pause the video, try the rest of these, and then here are the answers, and you can check your work. Okay, and this is where we'll stop for this particular section 7.2. Be sure you complete the form that goes with this, and if you have any questions, let me know. Thank you.